Hello everyone. Here I will shortly discuss a neural network called CLEEP, connecting text and images. That's a contrastive pre-training. So namely, we have pairs of caption and image collected from internet, and we have text encoder. It can be a transformer as well as an image encoder. It can be another transformer. And then we have embedding, that's 512-dimensional embedding for image and 512-dimensional embedding for text. And now we have pairs. And in this batch, because we have, for example, n captions and n images, and only pairs, they correspond to each other. And those which are not pairs, they do not correspond to each other. Therefore, for example, let's take number 3. So we have caption number 3 and image number 3. So they both are being transformed into two vectors. This is 512-dimensional vector, and also this is 512-dimensional vector. And the objective here is that the values of these vectors should be as close to each other as possible. So you can think about it as a point in 512-dimensional space. So imagine, just to make it visually easy to understand, like if you have a 3-dimensional space, and a point in 3-dimensional space has 3 coordinates, x, y, z, right? So this would be your vector of 3 values, x, y, z, which represent a point in 3-dimensional space. Or the same logic in a 512-dimensional space, where 512 values represent the coordinates of a point in a 512-dimensional space. The idea is that these 2 points, one from here and one from here, they should be as close to each other as possible. In this latent space, text embedding, the task of the text encoder should be to produce the position of this point, like to translate this text into such a point in the latent space that it's close to the translation of this image by image encoder to the same latent space. So this is a common latent space. You can call that multi-sensor latent space. So because like position in this latent space should be similar for visual modality and for text modality in this case. And this is the training objective. So because these are 2 points, we can produce gradients which will try to push these points closer to each other. Imagine that with gradients, we know how to update all weights in this encoder in order to make the position of image point closer to the text point. And with gradients, we also know how to slightly update weights of neurons in this text encoder such that we can move the point of text embedding a little bit closer towards the image embedding. This happens in the case of pair, but in the case of not pair, so that's basically some random text and some random picture, so they do not correspond to each other. We have a different objective. We want to push them apart in this latent space. And with gradients and backpropagation, we know how to update weights of connections in text encoder and image encoder in order to make them as far away as possible in this latent space. This can be used then in many different scenarios. One of the original scenario was, for example, if you want to categorize images. So you have an image, and then what you can do, you can just specify categories like bird, dog, car, plane, and then measure similarity between given text labels. So this is quite different to the previous type of architectures, so for example, YOLO, where you have a predefined set of labels, let's say 80 labels in YOLO case, in the standard YOLO case, and then you train that network to predict these labels. More progressive technique would be just to have an image and then possible labels and then measure similarity in this latent space between this image and these labels.